Computer Network. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about error control in data link layer. First, we will discuss about what is error in data link layer. Before that, in previous sessions, we already discussed about what is data link layer, what are the different types of layers in data link layer, that logical link control and MAC layer. These two layers already we discussed previously, and next we also discussed what is framing technique in data link layer. At the same time, we discussed what are the different design issues are there in data link layer. These are all topics we discussed in previous sessions. Now we are going to discussing about error control in data link layer. Let us see the overview of today's session. In error control, first we have to discuss what is an error, and next we will discuss about what are the different types of errors are there in error control, and next we have to see about the what is redundancy technique, and next we will discuss about what is error detection techniques are there, different error detection techniques are there for detecting the error, that we will see in today's topic. These are the different design detection techniques are, those are VRC, that is vertical redundancy check, and next we will discuss about LRC, longitudinal redundancy check, and next one is the checksum, and next finally we will discuss about CRC, that is cyclic redundancy check. These are all detection techniques we will see in today's session. First we will see what is an error. Error is nothing but it is a data. When suppose here is the sender, here is the receiver. So what exactly we call it as an error? So when the data is transmitted from the sender to the receiver, this is the transmission medium, right? This is the transmission medium. We are sending the data. We are sending the data using this transmission medium. So whenever the data is sending through this transmission medium, there may be chance to the data is going to be corrupted. That corrupted error is nothing but the error. Means the data is transmitted in the network. Whenever the data is transmitted, there may be chance to be corrupt the error. The data is going to be corrupted during the transmission is called as an error. Errors that are going to be occurred during the transmission is called as a transmission error. So when the error is going to be happen, that is called as the transmission error, because it is going to be happen during the transmission time, so that it is called as the transmission error. So for reliable communication, the error must be detected as well as the corrected. So if the sender is sending whatever data is sending, suppose if the sender is sending the data like this, right? Whenever the data is sending from the sender, exactly the receiver also receive the same data only. Then that is called as the reliable communication. For that reliable communication, the errors must be detected. If the error is going to be happen, we have to detect the error as well as the correct the error. That is the error control. And these error detection and correction, those can be implemented either at the data link layer as well as the transport layer in the OSI reference model. So OSI is having 7 layers, right? Like application layer, presentation layer, application layer, presentation, session layer, transport layer, network layer, data link layer and physical layer. Data link and physical layer. These are the 7 layers, right? So now we are discussing error control in data link layer, right? So whenever the error can be detected and correction in 2 layers, that is data link layer as well as the transport layer. If the error is come to here, that is comes under data link layer, means if the node to node delivery, this is the node to node delivery, right? This is the node to node delivery. When the error is happened in the node to node delivery, that is comes under the data link layer. If the error is comes under the network, if the error is there in the network, that is going to be solved by the transport layer. So error is going to be detected and corrected using the data link layer as well as the transport layer. That is in the OSI reference model. So what are the different types of errors are there? So there are 3 types of errors are there. First one is the single bit error, multiple bits error and the burst error. These are the 3 types of error. First, what is single bit error? Single bit error is nothing but a single bit. That means only 1 bit. Only 1 bit data unit that is going to be changed. That type of error is called as a single bit error. So suppose this is the sender. So sender data is what? 100,100,11010. So this is the sender data. So whatever the 0 is going to be there here, that is going to be changed here as the 1. When the receiver is received, the frame is like this: 101, 11010. This is the received frame, means Here one bit is going to be changed from 0 to 1. Means only one bit is going to be changed. That's why it is called as a single bit error. And next one is the multiple bits error. Multiple bits means more than one bit is going to be changed. That is called as the multiple bits error. Means more than one bits are going to be corrupted. That is a multiple bits error. So here this is the sender frame. What is the sender frame here? 100, 100, 11010. This is the sender frame. This is the actual data. So while coming to the receiver frame, what exactly receiver is received means that is 101, 100, 11. The receiver is received means here the 0 is changed as the 1 and the next 1 is changed to 0 and next 0 is changed to 1 means more than 1 bits are going to be corrupted here. So that type of error is called as the multiple bits error. And next burst error. What is burst error here? The received frame, whatever received frame is from the receiver side, that is more than one consecutive bits are going to be corrupted. Means consecutive means continuous bits are going to be corrupted. More than one, that is called as a burst error. See, this is the sender frame. See, this is the original data. It is going to be sent the 100111010. This is the sender original data. But the receiver is received data is 1010010. This is the receiver data. So here 0 is converted to 1. 1 is going to be changed as the 0 and 1 is going to be changed as a 0. Means this is going as a consecutive manner. So more than 1 bits are going to be changed in a consecutive manner. That is called as the burst error. These are the three types of error in error control. And next we will discuss how to detect these type of errors. So we discuss single bit error, multiple bits error and burst error. These are the different types of errors, right? How we have to detect the error? How exactly we have to detect the error? Where exactly error is happened? So error detection means to decide whether the received data is correct or not. Whether whatever receiver received, the data is correct or not is nothing but the error detection without copy of the original message. Means whatever original message is there, original data like 100, the exactly receiver is received 100 is not that is nothing but the detection, error detection. To detect or correct these type of errors, we need to send some extra bits with the data. Means whenever the actual data is there, this is the original data. So this is the original data. Whether this data is corrupted or not, how we have to check? Using, we have to add some extra bits to original data. Means I have to add 100 to this particular original data. That is nothing but the error detection and correction. If you want to detect or correct this particular data, if the data is going to be changed, that time we have to add some extra bits to the original data. That is the error detection. These extra bits, whatever adding these extra bits are there, these are called as the redundant bits. These are nothing but the redundant bits of the data. What is the exactly redundancy? First we have to see what is the redundancy here. Redundancy is the central concept for detecting and correcting the errors in the redundancy. That is called as the redundancy. To able to detect and correct the errors, we have to use the redundancy technique. First, we need to send some extra bits to with our original data. That is the redundancy concept. These redundancy bits are added by the sender and these are removed by the receiver. Means the bits are going to be added by the sender. Whatever receiver receives the data, that is removed by the receiver. The practice of adding extra and redundant data bits that are going to be transmitted information for detecting and correcting the errors that may occur during the transmission. That is the redundancy. See this picture, this is the original data. So this data is sending to the generating function. After accessing this original data, this generating function will generate the redundancy bit. So this is the redundancy bit that is going to be added to the original data. This is the redundancy bit that is going to be added to the original data. Whatever original data is there, that is going to be added here. And the whatever generating function is generating redundancy bit, that is going to be added to the original data, and total this data is sending to the receiver. So what receiver will do? Receiver is having the checking function. He will check with these redundancy bits. These are the redundancy bits. This is the original data. If the original data as it is there, it is going to be accepted, and if the data is not having the original data, then it is going to be rejected. That is the receiver side. Like this, the redundancy concept will work in error control. So what are the error detection and correction, how exactly it is going to be happen from the sender to the receiver. See here first the message, whatever message is going to be there, that is sender side is called as the encoder and the receiver side is called as the decoder. That is, we are encoding means we are adding extra bits to the original data. That is the encoding process. Decoding means we are removing the extra bits and we are checking the original data, that is called as the decoder. So this is the original matter, here message this is, and next this is going to convert it to the generator. The generator will check the add the original data with the redundancy bits, that is the message plus redundancy bit, and we are sending that data to the unreliable transmission media so that the data may be corrupted. That's why we are going to use the concept of error control. So the whatever receiver receives the information, that is going to be due to the checker. Receiver checker is there. He will check whether the data is going to be, whatever data is, the data is correct or not, and if the data is correct, it will show, and otherwise it will discard the packets. That is nothing but the error detection or correction. So what are the error detection techniques are there? These are the 4 types of error detection techniques are there. Those are the vertical redundancy check, that is VRC, longitudinal redundancy check, that is LRC, and next one is the checksum, and finally CRC, cyclic redundancy check. These are the 4 types of error detection techniques. First we will see what is VRC, that is vertical redundancy check. So it is also called as a parity check. So before going to discuss about the VRC, we have to discuss about the parity generators. What is parity generators are there? What are the different types of parity generators are there? These are the 2 types of parity generators are there. First one is the even parity generator and next one is the odd parity generators are there. These are the 2 types of parity generators. So even parity generator, what it will work, and odd parity generator, how it will work, we will see. So if it is even parity, if the original data, suppose we consider the original data is 110 like this, this is the original data. If based on this original data, we will work on even parity and odd parity. If the original data is having number of ones, it will check the number of ones. Number of ones is ones in this particular data. How many number of ones in this particular data? 1, 2, 3, 4. So if the number of ones is odd, suppose here one more one is there. If the number of ones in this particular data is odd number, means 1, 2, 3, 4, 5. Number of ones is how many? Total 5 number of ones are there. So if the number of ones is odd number, then we will assign that particular bit to 1. Means we have to add the redundancy bit as the 1. Suppose if the number of ones are even, then we have to add that to 0. That is the even parity. Opposite to even parity is the odd parity. Means same, this is only we have to take 110, 1101. If the number of ones in this particular data, how many number of ones are there here? Number of ones are odd is there. It is going to be added to 0. Means the redundancy bit we have to consider as a 0. If the number of ones are even, then we can call it as a 1. That is the redundancy bit we have to add. That is the difference between even parity and odd parity. So most of the cases in error detection, we have to go for the even parity generator. Even parity means what? If the number of ones in the particular data. So this is, take this example. Here now how many number of ones are there in the original data? So here only 3 ones. 1, 2, 3. 3 ones are there. Number of ones is odd. If the number of ones is odd, we have to, if we use the even parity, we have to append as a 1 bit as a redundancy bit. So here we can, here we are using the 1 bit as the even parity generator. That is the VRC. So the whatever data is going to be there, original data, along with the original data, we have to send to the receiver as a 1 bit extra. That is the redundancy bit. So the data is transferred to the receiver along with the parity bit. Means parity bit is nothing but the redundancy bit. So what receiver will understand? But first receiver will check the number of ones in the data. This he is considered as this is the parity bit. If the parity bit means 1, means what it will understand? Number of 1 this particular data is going to be odd number. Means here you will check 1, 2, 3. So 3 ones are there. Means okay, the data is whatever data is sending from the sender, I will receive that data only. So receiver will accept the data. That is nothing but he will accept the data. That is the error detection technique in VRC. So here see we write here VRC is nothing but if the number of ones, odd number of ones is there, we have to append as a 1. If the number of ones are the even number of ones, we have to append to the 0 is the original data. That is the VRC, vertical redundancy check. And how the performance is going on the VRC here? So it can detect the single bit error. Single bit error means only one error is there, it can solve easily. If that means whatever data is sending from the sender to the receiver, if only one bit is going to be changed, it can detect the error easily. And it can detect the multiple bits error. When it is going to be detect the multiple bits error, only if the number of errors is going to be odd, that time only it is going to be detected. See how it is. If the sender data is like this 111000001, this is the original data. So how we are checking the errors means the receiver receives data is this one 101000001. So here 1 is going to be changed to 0. Only one bit is going to be changed. So it can detect the single bit error already, which I said that. So receiver rejects the data. So here is error is there. I am rejecting the data like that. He will reject the data. That is the 101000001 is going to be rejected. That is the single bit error. And coming to multiple bit error. Multiple bit error, when it is going to be accepted, number of errors is going to be odd, then only means like odd means 1, 3, 5, 7, 9 like this only number of errors, then it is going to be detect the error. But see this example here the original data is 111000001. This is the original data. So whatever receiver receives data is, if this 1 is changed as a 0 and this 0 is changed as a 1. So two bits, even bits are going to be changed here. So what receiver will understand? Receiver will accept the data without identifying without detecting the error, it will accept the data because here 2 bits only going to be changed. This case is not work in VRC. So that whatever the odd number of errors are going to be there, then only it will identify the error in VRC. That is the disadvantage of VRC. And next, what is LRC? Longitudinal redundancy check. So longitudinal means the block of bits, whatever bits are there that are going to be organized in rows as well as the columns. From row wise and column wise, we are going to check the redundancy bits. So here it is also called as the two-dimensional parity. So LRC is also called as a two-dimensional parity. The parity bit means whatever redundancy bit that are going to be calculated for the each column and sent along with the data. Means it is going to be added for each column wise and sent along with the original data. The block of this parity act as the redundancy bits. Whatever we are going to be added, those are called as the redundancy bits. So see this example, you can clear this concept. So first these are the example for LRC. So this is the one block, this is the one block, this is the one block, this is the one block. Means these are different blocks are there. The blocks of bits means each block is containing the bits. So these block of bits are going to be arranged as a row wise as well as the column wise. So whatever data is there, that we arrange in a row wise and column wise here. Row wise and column wise we arrange. That is the first one. This is the first one. This is the second one. Here is the second one. And this is the third one. Third block. Here is the third one. This is the fourth one. This is the fourth one. We arranged as a row wise and column wise. And then we have to go for the parity. We have to go for the parity checking for adding the redundancy bits. So parity concept is what? If we go for the even concept, the even parity concept, what is the concept here? If number of ones are there in that particular block, then we have to add the 1. If number of ones are the even, then we have to add the 0. So first we will see this row. First this row we will check first. So how many number of ones are there in this particular column? Total 4 number of ones means even number of ones are there. We have to add the 0. And next column is how many number of ones are there? Next only 1 is there. So that it is going to be number of ones is odd. It is going to be appended as 1. And next column, if we check this column, so here number of ones, how many number of ones are there? Total 2 are there, 1 and 2. So number of ones are even means we have to append with the 0. And the next column is number of ones here, how many are there? Total 3 are there. So if 3 are there, number of ones is odd means we have to append with the 1. And next here is 2 ones are there. So it is going to be 0. And next here in this column total how many number of ones? 3 ones means odd number of ones means we have to append with the 1. And next column here how many ones are there? 1, 2, 2 ones are there means we have to append with the 0, and finally it is going to be 1, 1, 2, 3. 3 ones are there means it is going to be append with the 1. Like this, we have to append the redundancy bit, LRC bit, that is the parity bit. So, based on the even parity generator concept, we have to check the redundancy. So, how it is going to be appended with the original data? See, this is the original data. Whatever first one, this is the first one, this is the second one, third one, fourth block, and whatever LRC we said, right, that it is appended to the here. That is the LRC 1010 1010 along with the original data. We are going to add the redundancy bit, that is the parity bit also. Like this, the data is sending from the sender to the receiver. So this is the LRC for detecting the errors. So what is the performance of the LRC here? LRC increases when compared to the previous, that is the VRC, vertical redundancy check. It is having some better compared to the VRC for detecting the multiple bit errors. So if the 2 bits, when it is going to be fail, some cases means if the 2 bits are in one data, units are going to be damaged, means in particular data unit, in particular these particular data units, 2 bits are going to be damaged. That time it may be not possible, means here the data is 10 coming to this 100 00 100. 2 bits are going to be changing here. Suppose this data and this data, if I am changing 2 bits, like if 0 is converted to 1, 1 is going to be converted to 0. If I am changing to 2 bits, 10 100, like this, if I change it, there is no meaning, means it will give the same result. Here also number of ones is even, means what? It is going to be appended to 0. Here also number of ones is 0, number of ones is even, means it is going to be appended to 0. Means if the case 2 bits of one data unit are going to be damaged, it will not work. At the same time, 2 bits in the exactly the same positions in the another data. So this is one data and this is another data. Suppose here is 1 is there, here is 0 is there, right? If it is going to be changed as, if it is a 0, if it is a 1, means here also 0 and 1 means here also how many ones are there? 1, 2. 2 ones are there means it will give the 0 only. If 2 bits are going to be changed in the same position in the other data unit also, it is going to be it will not give the accurate result. That is also case in the LRC. LRC checker will not detect the error that time. That is the performance of the LRC. So here it is, we already said it is also called as a 2-dimensional parity, right? How the 2-dimensional parity work here means, this is the original data. 2-dimensional means we have to calculate as a row wise and column wise, both we have to calculate. See here, this is the original data. Row parity we are checking, at the same time column parity also we are adding. See now how many number of ones as a row wise? 1 2 3 4. 4 ones means even number of ones, we have to add 0. Here also 1 2 3 4. 4 ones means even, we are adding 0. At the same time 1 2. 2 ones are there means even, we are adding 0. Here 1 2. 2 ones are there, we are adding 0. This is the row parity. And again we have to check the same column parity. Like this we have to check column parity. Here is 0 means here is 0. And next column parity coming to here is only 1 1, it is 1. And next here is also 1, here is 2 ones are there, that is 0. Here is only 1, here is only 1, here is 2 ones, it is 0. Here is only 1, it is 1. Here is only 3 ones are there, that is the 1. Like this 3 ones are there means it is 1. So this is the column parity, this is the row parity. Like this we have to consider as a 2-dimensional parity check. How it is going to be added to the original data? See here first. So this is the original data 100 1100. Here 100 11001 till here it is the original data and we are adding 0. This is the next, this is the first, second, third and fourth. So first, second, third, fourth, and we are adding the extra, whatever extra is there we are adding with that extra. And this is the fourth one, we are adding with extra, and whatever final received column is there, that is the redundancy bit that we added here. At the same time this 0 is added here. Like this we are going to work with the 2-dimensional parity check in LRC. And coming to today's summary, first we discussed what is an error, and next we discussed what are the different types of errors are there in the error control, and next we discussed what is the redundancy concept in the data link layer using in error control, and next we discussed what are the error detection techniques are there, like VRC, that is vertical redundancy check, and longitudinal redundancy check. These two topics we discussed in today's session. And next session we discuss about what is checksum, how we have detect the errors using the checksum concept. At the same time, next is CRC, cyclic redundancy check. These two topics we are discussing next session. Thank you.